Hi everyone, I'm A. Nirisha, Assistant Professor in the Department of CSIT working in MLR Institution of Technology. Today in this lecture, we are going to discuss about searching techniques. So there are two types of searching techniques. Those are linear search and binary search. So coming to the overview, so we are going to discuss about the linear search, the concept and also the application as well as the program of the linear search. And also the binary search, the concept, application and also the program of the binary search, how it is implemented in the C programming language. So what is the concept of that linear and binary search and how those concept is implemented using C programming language. So the program implementation part also we are going to discuss. So coming to the linear search. So linear search is also known as a sequential search. So it is a method of finding an element within a list. In a group of elements, in an array, consider. So in an array, we want to search an element. So to search an element, we are using this linear and binary search. So it is sequentially checks each element of the list until a match is found or the whole list has been searched. So consider you are taking an array. So array is nothing but collection of multiple elements. So that we already discussed. So array is an array consists of multiple elements. So multiple data elements, multiple integer values, multiple float values or multiple character values. So consider we are going to take some integer values. So in that integer values, we want to find the position of one element. So position of one particular element. So that element you are searching where it is in the array and you are finding the position. The position is nothing but the index value. So index value of that particular element in an array or in the list. So given an array, so array of n integers and an n integer element x. So find whether the element x is present in the array or not. So it returns the index of the first occurrence of the x in the array or it returns -1 if it doesn't exist. So if you are going to use functions, so in that functions, it is going to return the index position if the element is present. If not, we are returning the -1, which is indirectly we are telling the element is not present in the list. In linear search, we iterate over all elements of the array and check if it in the current element is equal to the target element or not. So if you find any element to be equal to the target element, then return the index of the current element. Otherwise, if no element is equal to the target element, then -1 is returned as element is not found. So linear search is also known as a sequential search. So coming to the applications of the linear search. So in an unsorted list, we can search an element by using this linear search concept. So if the elements are not in sorted way, then are not in an ascending or descending order. So in that case also we can use this linear search concept. So if you have an unsorted array or list, linear search is most commonly used to find an element in the collection. So we can also use this linear search concept in small data sets. So linear search is preferably over binary search when we have small data sets. So we have only whenever we have some limited amount of numbers or limited amount of data, at that time we can use this a linear search. So searching linked list. In linked list implementation, linear search is commonly used to find the elements within the list. Each node is checked sequentially until the desired element is found. So simple implementation, linear search is much easier to understand and implement as compared to the binary search or the ternary search. So coming to the concept of the linear search. So we are going to select an element, what the element you want to search in an array. Initially we are taking an array and in that array we are asking to search a particular element. We are asking to find the element which you want to search. So that element you are comparing with each and every element in an array. So this is the concept of the linear search. So we'll discuss it with some examples. So consider my array consists of, so this is my array. It consists of some elements. So here we can also use sorted or unsorted. So this linear search is mainly famous for the unsorted list. So for unsorted list also we can use the linear search concept. So consider the elements are here 5, 10, 15, 12, 16, 30 and some 8. So these are the elements that we have in my array. And here the index starts from array index starts from 0. So the first element index starts from 0, 1, 2, 3, 4, 5 and 6. So here we have some 7 elements. So the 7 elements are we have placed in an array. So consider the element, the key element that I want to search, the target element or the key element, the element which you want to search, that I am taking it as a key. So the key value, I want to search this 16 element. So I want to find the index position of this 16 element in this array, in this particular array. So the 16 element. So we need to find whether the element is present or not. If it is present, in which index position it is present. So we need to compare this key with each and every element in this array. So for example, we need to compare this key with 5. So how to access this 5 element in an array? By using A of 0. So we need to check whether this key is matching with A of 0 or not. So key value is 16 and the A of 0 value is 5. So it is not matching. So we need to check the same element that is matching with the second element or not. So here the key is 16 and the second element A of 1 is 10. So here also the condition is false. That is not matching with the second element even. So now the key element we need to check with, we need to compare with A of 2. This is A of 1 and this A of 10 is A of 1 and it is not matching with 1 also, 1 index position element also. So we need to increment the index value and we need to check with the other element. So key is 16 and A of 2 value is 15. No, here also it is not matching. So we need to increment this index position. So now we need to check whether the key is matching with A of 3 or not. So here key is 16 and A of 3 is 12. No, here also the condition is a false. And we are checking with key is matching with A of 4 or not. Here A of 4 is 16 and also the key is 16. So here the condition is true and you are telling the target element, the element which you want to search is found at the 4th index position. As the array index is starting from 0 and we are counting the numbers from 1. So we are telling the element is present in this index plus 1 position, that is in the 5th position. See, here array index is starting from 0 but we are counting from 1. So if we are counting from 1, so the value it will be 1, 2, 3, 4, 5, 6 and 7. So 7 elements we are using and in that the 16th element is found in the 5th index, 5th position. So as per the array it is in the 4th index position, but as per the humans we are counting the numbers from 1, 2, 3 and so on. So we are taking the value as a 5th position. So it is the element is found in the 5th position in the list. And this is the program of the linear search. So here we are using functions and we are finding the linear search. We are implementing the linear search concept. Without using functions also we can implement the linear search concept. So as we know, the compiler starts reading from the main function. So here we are using the main function. So from here the compiler starts executing each and every statement. So here in the next we have declared an array. So the array elements here we have as 2, 3, 4, 10 and 40. Here the array elements we can also use in a random way. So here the elements are sorted in an ascending order. So we can also use some random elements for this linear search concept, not only in some sorted list. And here we need to find the x is equals to 10. The element that I want to search is 10 and that 10 element I am placing in the x variable. You can also take it as a key variable. And then next, by using this search is a function call. Search is a function call and this is a function, a definition here. So we are calling this function, search is my function name and we are calling this function name by using that function name. And here the parameters, how many parameters we are passing? We are passing some 3 parameters. One is the array and the next one is the how many elements you have in this, nothing but the size of the array, how many elements you have in that array, and the next x is nothing but the which element you want to search in an array. So whenever we call this function, what happens? Automatically the compiler will go to the function definition. The control will switch to the function definition. So this, we are passing this array, entire array to the function. So how to pass an entire array? By passing its array name. So in the array name itself, we have the base address. Base address is nothing but the first element address. So we are passing the address of that first element to the function. So thus ARR, whatever the address we have, that will be stored in this, that will be assigned to this another ARR. So this is a local variable, here this is a local variable, and this is formal variables. In formal parameters, the formal parameters are also equal to the local parameters, local variables. So this ARR address is passed to the another ARR address, and all the elements will be shifted to this array. And whatever the phi you have, that phi value will be copied to this n, and x value, whatever the x value you have taken, that is 10, the 10 will be copied to this another x. So as we know, for the local variables, the scope and lifetime is within the block. We cannot use the whatever the values that we have assigned for this in this block, that we cannot use in the another user defined block. So that is the reason why we are passing all the values to the functions. So now x value to be copied to this x, and here we are taking the logic like, so we need to compare each and every element. So to compare that each and every element, in the previous example we have seen, so we are taking 1, 2, 3, 4 and 5 iterations. So 5 times we need to repeat the same logic. So for that, what we are doing, we are using the loops concept here. So for that, we are taking for, and here for I is equals to 0. From where we are searching, from the 0th index position onwards, we are searching an element till n value. So how many elements we have in that array? So till that array size we are searching it. And then next, inside this for, we are writing the logic as this ARR of I is matching with the key element or not, which is nothing but x. So here x value is 10. So here I value is 0. So from 0 index we are searching it. So the 0 index element is 2. So 2 double equals to 10. No, the condition is a false here. So initially I is equals to 0, and 0 less than, here n value is 5. The condition in for is true, and the condition in if is, and this if is a false. And the next, so these two statements belongs to for. So we are done with this statement. We are done with the condition in the if the condition is false. So what we are doing, we are incrementing the I value. So now the I value will be equals to 1, and 1 less than 5. Yes, it is true. So if it is true, we are checking the condition. So next index element we are checking, it is matching with the x or not. So here a of 1 is 3. So 3 double equals to 10, false. So again, what will happen? I will be incremented, I will be equals to 2, and 2 less than 5, the condition is true. And in the second index position, we have the value as 4. So 4 double equals to 10, false. Again, what happens? I is equals to 3, and 3 less than 5. 3 less than 5 is true. And here in the third index position, so this is 0 index, 1, 2, 3, 4. So these are the index values. And in the third index value, we have, see, A of I is A of 3. A of 3 is 10. So 10 double equals to 10. Yes, here the condition is true. So what we are returning here? We are returning the I value. So what is the I value here? 3. So the 3 will be returned, and that 3 will be stored in this result variable. Whatever the value you are, it is returning from this search function. So that value we are assigning to this result variable. So now the result value is 3. So we are checking if 3 double equals to a minus 1. So why we are using this minus 1? See, here the 10 value is present in this list. For suppose, if you are searching for the element which is not present in the list, so we need to know something to identify that element is not present. So if the element is not present, so we are returning a minus 1. If the element is present, then we are returning the index value of that particular array element. So here the condition is false. So if it is false, it will come to the else part, and here we are telling element is present in percentile D position. So here the percentile D is nothing but the result value. Whatever the value that is stored in the result, that is the index position. So the 3 index value is stored in that result. So here the value will be, here in the place of this control string, the value will be 3. So here we can check the test case element is present at index 3. So for suppose, here we know the array index is counting from 0. For suppose if we want the humans count, so at that time here we can use result plus 1. So which means 3 plus 1, that is 4th. So it is in the 4th position. So if you count from 1, 2, 3, 4. So it is in the 4th position. So if you want the array index, exact array index, then you can use the same result. So if you want the human count, so at that time you need to use plus 1. You need to add plus 1 to it. So this is about a linear search. And the next one is a binary search. So binary search is a searching algorithm operates on sorted or monolithic search. So repeatedly dividing it into halves to target a target value or optimal answer in the logarithmic value. So here the best to follow the steps for the binary search. Here we are doing the divide and search space into 2 halves by finding the middle index mid. So before going to the binary search, we'll start with a small example. So for suppose if you are searching for a word in the dictionary, so that time what you do, you will open the dictionary in the middle and you will check whether it was in the left side or it was in the right side. If it is in the left side, you will open in the left side, you will go to the left side index. If it is in the right side, you will go to the right side alphabetic word. So in the same way, the same concept we are applying it in the binary search. Here we are finding the mid value. So after finding the mid value, we are comparing the mid value with the key element. That is key here is nothing but the search, the element which you want to search. So that search element you are comparing. So if it is matching with the mid value, then we are telling the search is terminated. If it is not matching with the mid value, we are checking whether the key is less than mid or whether the key is greater than mid. If the key is less than mid, then we are searching in the left side. If the key is greater than mid, then we are searching in the right side. So that is the reason why we are using divide and conquer concept here. So here we are dividing this search into 2 halves, and here we are finding the middle index and then comparing the middle element of this search space with the key. So if the key is found at the middle element, then the process is terminated. If the key is not found at the middle element, then we are choosing any other next search. That is, if key is smaller than the middle element, then the left side is used for the next search. If the key is larger than middle element, then we are using the right side for the next search. So this process is continued until the key is found. The total search space is exhausted. So applications of the binary search. Searching in only sorted arrays. So we can search an element only in the sorted arrays. If the elements are in unsorted array, we cannot use this binary search concept. And finding last and first occurrence or closed match in a sorted array. And database indexing used a B tree and similar structures for data lookup, fast data lookup. And debugging and version control. Tools like Biscuit use binary search to isolate comments. So network routing and IP lookups. So efficiently finding routing entries in tables sorted by address ranges. So these are all nothing but the applications. So by using the binary search, all these applications have been designed. So here we are also using some file systems and libraries, fast search through sorted directories or symbol tables, and gaming graphics and also machine learning tunic. All these things we are using this binary search concept. And coming to an example of this binary search. So consider these are the elements that we are going to take here. And as we discussed, the binary search concept is only for the sorted list. So for the unsorted list, we cannot use this binary search concept because we are comparing and we are checking whether the middle element is less than or greater than. If it is less than, we are ignoring the right half and we are searching in the left half. If it is greater than, we are ignoring the left half and we are searching in the right half. So make sure that when you are applying the binary search, the element should be in the sorted order. So here we are taking the elements as 10, 20, 30, 40, 50, 60 and 70. So here the index starts from 0, 1, 2, 3, 4, 5, 6. So here total 7 elements we are using in this array. And you can check all the array elements are in a sorted way. So here we are finding the middle element. So here the middle, how to find the middle element? So we need to add the low and high value and divide it by 2. The addition of low and high, we need to divide it by 2. So then we'll get the middle element. So this is nothing but the low value. Low is 0 and high is the 6. So here the low value is equals to 0 and high value is equals to 6. So we're finding the mid value here. So middle is equals to low plus high by 2. So here low is equals to 0 plus high 6 by 2. So we'll get 3 by 2 here, 6 by 2. So 6 by 2 will be equals to, so 6 by 2 will be is equals to 3. So now the mid value is equals to 3. So by using this middle element, so how we'll get the middle element? By using this index, mid index value. So we are getting the middle element. So we can find. So this value is nothing but the mid value. So if it is mid value, then we are checking that middle element with the key. So initially, before finding the mid value, we need to find the element which you want to search. The element which I want to search, I am storing in the key variable. So if the key value is equals to, consider some 60. So I want to search an 60 element in it. So the 60 will be stored in that key variable or X variable, as we have taken the variable in the lean usage. So now this middle element, this is a middle element. So this middle element we need to compare with the key element. If it is matching, then the searching technique will be terminated. If it is not matching, we are checking if it is less than or greater than. So here we need to find. So A of mid, we need to check whether is A of mid is double equals to key. So here mid value is 3. So A of 3 is 40. So 40 double equals to key here is 60. The other condition is false. And now we need to check whether the middle element is less than key or greater than key. So now if A of mid less than key. So A of mid value is 3. A of 3 is 40. 40 less than 60. So 40 is less than 60. So if 40 is less than 60, then what we need to do? We need to search the element in the next half, which is in the right half. So here for that we have the high value. The high value is 6, but we don't have the low value. So here we need to move the low value to here. So which is mid plus 1. So here the 40 is less than 60. 40 less than 60 it is 2. So what we are doing? We are moving the low value to mid plus 1. For suppose, if you are searching in the second example, if you are searching whether my key is equals to, consider it is 20. So for suppose we are searching for key is equals to 20. Here in this example we are searching, this is one example and this is another example. In this example we are taking key as a 60, but in the next example we are taking key as a 20. So in the first search, 40 double equals to A of mid is 40 here. Same. 40 double equals to 20. Here the condition is false. So we are checking for the next A of mid less than key. So A of mid is less than key, that is 40 less than 20. Key value is 20. So 40 less than 20. Here also the condition is false. So what the another option we need to check whether this A of mid is greater than. So here A of mid is 40. 40 greater than. Here key is 20. Yes, here it is true. So if it is true, then we need to search in the first half. So here we have the low value here. Low is equals to 0. We need to change the high value. So if this condition is true, we need to change the high value. High is equals to mid minus 1. So which means we need to search till this array now. For suppose if you are taking key is equals to 20. For suppose if you are taking key is equals to 60, then we need to search in this array. Here the low value is mid plus 1 and high value is same. It is not changing. So this process should be continued till the element is found to the middle element, mid value. Element is matching with the middle element. If it is not, if any of the element is not matching with the middle element, then the element is not found in that list. So this is an example of the binary search. So here also there is the searching starts from the compiler starts execution from the main function. So this is the array 2, 7, 9, 10, 9, 50. So here we are taking the 10, we are taking the x is equals to 10, that is nothing but the element which you want to search. And in result, we are calling a binary search. The binary search is a function call, and to this function call, we are passing the array and also the size of the array and also the element that you want to search. So that will be these, all the values will be copied over here. And the next we are you can find here, we are taking low is equals to 0, high is equals to n minus 1, and we are finding the middle element. Low plus high by 2 is equals to 2, or also you can also take low plus high minus low by 2. So both the values you can take. And if this a of mid is double equals to x, then we are returning the middle element. That middle element we are returning. So if it is not true, then at that time a of mid less than x. If it is less than x, then we are changing the low is equals to mid plus 1. Else we are taking the high is equals to mid minus 1. So here in this example, 20 less than 60, which means the low value we are changing to the mid plus 1. So the high value will be 6 and low value will be mid plus 1. So here mid is equals to 3. So 3 plus 1 will be equals to 4. So again we are finding the mid value. This is the first iteration and this is the second iteration. So mid is equals to 4 plus 6. So low is 4, high is 6. So 4 plus 6 is 10. 10 by 2, that is equals to 5. So the same process, this middle element we are comparing with the key. So in this, a of mid double equals to key. A of mid is a of 5. A of 5 is 60 and the key is also 60. Yes, here the key is matching. So if the key is matching, then at that time what we are doing, we are returning that index value. So the index value is stored in this mid value. So that is the reason why here we are asking to return. If this is matching, then we are asking to return mid. And this process, the finding of the mid value and changing the low and high value, this process is continued till this condition, till low is less than or equals to high. So this mid value is returning here if any value is not present. So if the element is not found in that array, then we are returning the minus 1. So here we are checking with the condition. So the value will be stored in this result. So here we are checking result equals to minus 1. So if it is the result, whatever the value that we are returning. So here the x value is 10 and here 0, 1, 2, 3, 4. So these are the index positions. So the index position is 3. So the 3 value is returning after this completion of this process, termination of that while loop. The 3 value will be returned here and it will be stored in the result variable. And 3 double equals to minus 1. The condition is false and we are telling it is coming to the else part and we are telling element is present in this particular index. In which index position? In the third index position. Element is present in at index 3. So this is about binary search. So the difference between linear and binary searches. In the linear search, we are searching each and every element in an array. So whereas coming to the binary search, we are dividing the array elements or dividing the list of the elements into the two halves. And by using the middle element, we are searching in the left half or the right half. So divide and conquer process we are using in the binary search. So the binary search concept is used for huge data sets, data elements. But whereas coming to the linear search, we are using only for small data elements, small data sets. And next, the linear search, the elements can be in a random order. But coming to the binary search, the element should be in the sorted order. Then only we can apply the binary search logic. Thank you.